Living with fire ants is part of life here at the moment in southeast Queensland, but the next stage of the eradication program will determine if it's something that stops here or spreads potentially to the rest of the country.
Australia is facing a shocking event in its wild lands. New footage shows millions of ants attacking billions of poisonous invasive animals with fierce speed. What started as a small experiment has become a chaotic scene in nature. These tiny ants, armed with stings and huge numbers, are reshaping the ecosystem by targeting animals that once had no enemies.
Some 70% of fire ant nests are detected as a result of public tip-offs. If you find one, it's important you leave it alone and immediately report it online or by phoning Biosecurity Queensland.
Scientists are amazed. But what happens next? And can anyone stop it? Watch as we reveal the details. Ants attack millions of invasive poisonous animals in Australia. In the year 1935, a decision was made in Australia that, at the time, sounded simple, practical, and honestly quite clever. Farmers were facing a serious problem. Their sugarcane crops were under attack by beetles, and these insects were causing real damage. The crops were being eaten, profits were dropping, and something had to be done. So, a solution was introduced. Cane toads were brought in from another part of the world. The idea behind this move was very direct. These toads would eat the beetles. The beetles would disappear. The farms would recover. Everything would go back to normal. But that is not what happened. Instead, the beetles continued to live and grow. They were not controlled in the way people had expected. At the same time, something else started to happen. Slowly at first, and then much faster. The cane toads began to multiply, and they did not just grow in small numbers. They increased rapidly, spreading into new areas, moving further and further away from where they were first released. What started as a controlled introduction quickly became something much harder to manage. One of the main reasons for this was the toads themselves. They were not ordinary animals. They had a powerful defense built directly into their bodies. Their skin produced a strong toxin. This toxin was not mild. It was extremely dangerous. Any animal that tried to eat the toad could be poisoned. Snakes, lizards, small mammals, and even larger animals could die after attacking or eating a cane toad. These predators had no warning. They treated the toad like any other prey, but the result was often fatal. The toxin affected the heart, the nerves, and the breathing system. It worked quickly and left little chance of survival. Because of this, the cane toads faced very little resistance in their new environment. The animals that would normally control their population were being removed instead. Predators were dying, and the toads were surviving. At the same time, the toads were reproducing at a very high rate. They laid large numbers of eggs, and many of those eggs developed into tadpoles. Over time, more and more toads were being added to the population. And as the population grew, their spread across the land became faster. At first, their movement was slow. They expanded only small distances each year. But as their numbers increased, that pace changed. Larger populations meant more movement, more breeding, and more expansion. Over the years, they began to cover large parts of the landscape. They were no longer just a farm solution. They had become a widespread environmental problem. They ate almost anything they could swallow. They competed with native species for food. And most importantly, they poisoned the animals that tried to prey on them. This created a chain reaction. As predators disappeared, other parts of the ecosystem were affected as well. It began to look like the cane toads had no real weakness. They were toxic, fast-spreading, and highly adaptable. Nothing seemed able to stop them. But this was not entirely true. There was a moment in their life when they were not strong. A moment when all their advantages were reduced and their weaknesses became clear. This moment came right after they changed from tadpoles into small toads. At this stage, they left the water and moved onto land. And this is where everything changed for them. The young toads, often called toadlets, were very different from the adults. They were small and soft. Their bodies were still developing. Their muscles were not fully strong. Their movement was slow and not very effective. They could not jump far, and they became tired very quickly. On top of that, they had another problem. They lost water from their bodies very fast. This meant they could not travel far away from moist areas. They were forced to stay close to the edge of the water. Because of this, large numbers of them gathered in one place at the same time. Hundreds of tiny toads would emerge together, all moving slowly, all trying to survive. And this is exactly where they became vulnerable. Along the edges of these water areas lived ants. Many ants. These ants were always active, always searching for food, always ready to respond to movement. When the young toads appeared, the ants noticed immediately. What followed was fast and overwhelming. The ants moved in large numbers. They surrounded the toads. They climbed onto their bodies. They bit and held on tightly. The toads tried to escape, but they were too slow. They twisted and jumped, but it made little difference. And here, something very important became clear. The toxin that protected the toads from large animals did not stop the ants. How exactly do such small creatures like ants turn this brief moment into such a deadly and powerful attack? Let's take a closer look. Small creatures, big impact, and a careful way forward. As the young cane toads struggled along the edge of the water, their situation became even more difficult. The place where they had to move, the shoreline, was not safe or simple. It may have looked like an ordinary strip of land, but for these tiny animals it was full of danger. The ground was uneven. There were small holes, cracks, and dips. There were marks left by other animals, like hoof prints. To a human, these might seem like small details, but to a tiny toad, they were serious obstacles. Each small dip could slow them down. Each crack could trap them for a moment. And every moment they lost increased their chances of being found. The ants were already there, moving across this same space. They were used to the area, they knew it well, and they were always searching. When a toad moved, struggled, or made any kind of disturbance, it became easy to detect. The ants responded quickly. They gathered in groups and attacked together. This group behavior made them extremely effective. A single ant was not a major threat, but dozens working together could overpower the young toads. They bit, they held, and they covered the prey in large numbers. Many toads died very quickly once the attack began. Even those that managed to escape were often badly injured. They were weak, stressed, and damaged. Within a short time, most of them still died. Escaping the ants did not mean survival. It only delayed the outcome. This meant that the ants were not just affecting a few individuals, they were reducing entire groups of young toads at once. They were hitting the population at a critical stage. However, even with this strong impact, the ants were not able to completely stop the spread of cane toads. The effect of the ants depended on many conditions. In some places, everything worked in their favor. The ground made movement difficult for the toads. The weather supported high ant activity. The shoreline forced the toads into tight spaces. In these areas, many toads were lost. But in other places, the situation was different. There might be fewer ants. The ground might offer more hiding spots. The conditions might allow more toads to escape. Some toads found ways to climb onto objects or reach places where ants could not follow. Because of this, the impact of the ants remained local. Strong in some areas, weak in others. At the same time, ants were not the only predators involved. Other small creatures also played a role. Some insects fed on the eggs, others attacked the tadpoles while they were still in the water. This meant that the cane toads faced pressure at multiple stages of their life. Eggs were attacked first, then tadpoles, then young toads on land. This created a layered system of control. Not one single solution, but several small pressures working together. Still, this combined effort was not enough to fully remove the cane toads. Their numbers were too large, and their spread was too wide. It might seem like the next step would be to introduce a stronger predator, something more powerful that could control the toads more effectively. But this approach carries serious risks. Bringing in a new species can create new problems. That species might not only attack the cane toads, it could also harm native animals, damage the environment, and create another imbalance. Instead of solving the issue, it could make things worse. Because of this, a more careful approach is needed. Rather than adding new threats, the focus is on using what already exists, understanding the natural predators, like ants, and supporting their role in a controlled way. For example, increasing ant activity in areas where young toads gather can make a difference. This does not mean forcing or controlling nature completely. It means guiding it carefully. In the end, the story shows something important. The cane toad is strong, toxic, and difficult to stop, but it is not completely untouchable. At one stage in its life, it becomes weak, and at that moment, even the smallest creatures can make a difference. Nature does not always fight back with something big or obvious. Sometimes it responds in quiet, steady ways, and sometimes that is where the real impact begins. From just a few dozen toads released decades ago, how did their numbers explode into the hundreds of millions we see today? Stay tuned for more details. The growing scale and the endless cycle. The size of the cane toad population in Australia has become something that is very hard to fully take in at first glance. What started as a small number has, over time, slowly and steadily grown into something much larger than anyone expected. Today, the number of cane toads is estimated to be more than 200 million. That number alone already sounds very large, but when it is compared to other things, it becomes even more striking. The population of these toads is now said to be around 8 times larger than the number of people living in Australia. When compared to animals, it is even more surprising, as there are believed to be about 20 times more cane toads than all the koalas combined. The spread of these toads across the land has also been very wide and very steady. They have covered more than 1.3 million square kilometers. This did not happen all at once or in a short period of time. Instead, it happened slowly, over many years, almost in a quiet way that was easy to overlook at first. But as time passed, the numbers kept increasing, and the area they covered kept growing, until it became a very serious and very noticeable problem. A big reason why this population has grown so large comes down to how these toads reproduce. The way they reproduce is not just fast, but extremely fast when compared to many other animals. A single female cane toad can lay between 20,000 and 30,000 eggs in just one breeding cycle. That alone is already a huge number, but it does not stop there. This process can happen twice in 1 year. When this is repeated again and again across millions of toads, the result becomes something much bigger than what most people would expect. When all of these numbers are added together, it leads to billions of eggs being released into the environment every single year. That means that even if a large number of them do not survive, there are still more than enough left to continue growing the population. It creates a cycle that keeps repeating itself over and over again. Even if some toads are removed, even if many do not make it to adulthood, the population still finds a way to recover very quickly. This fast and constant reproduction also makes it very difficult to control the population in any lasting way. Efforts have been made over time to try and reduce their numbers. People have gone out to collect them by hand, traps have been set, and organized efforts have taken place to remove as many as possible. In many cases, millions of toads have been removed each year. At first, this might seem like a strong and effective response. It may even appear, for a short time, that progress is being made. However, the reality is quite different. Despite all of these efforts, the total population has not shown any real long-term decrease. The reason for this is simple, but also very frustrating. The toads reproduce so quickly and in such large numbers that they are able to replace what is lost almost as fast as it is removed. This creates a situation where the effort continues, but the overall problem remains. Because of this, it has become clear that focusing only on adult toads is not enough. Adult toads are already spread out, already established, and already difficult to manage. This has led to a shift in thinking. Instead of trying to control the problem at the later stage, attention has started to move toward the earlier stages of the toad's life. The early stages, which include eggs and tadpoles, offer a different kind of opportunity. These stages are usually found in water, in more concentrated areas, and they are not as strong or as difficult to deal with as adult toads. Because of this, they are seen as a more practical point of focus. By targeting these early stages, there is a better chance of reducing the number of toads before they grow, spread, and begin the cycle all over again. This shift does not solve the problem instantly, but it represents a different way of approaching it. It is a move away from reacting to the problem after it has already grown, and toward trying to stop it earlier, before it becomes much harder to control. Now that cane toads have multiplied beyond imagination, what has their unstoppable spread cost Australia? How has it changed the landscape? And what are scientists doing to try to control it? Let's find out. The cost, the change, and the search for control. The presence of cane toads has not only affected the environment, but it has also created serious economic problems over time. The total cost of the damage linked to these toads has been estimated to go beyond $2 billion. This is not a small amount, and it does not come from just one source. Instead, it builds up across different areas, slowly adding pressure over time. One of the main areas affected is agriculture. Farming systems can be disturbed in ways that are not always immediately obvious, but become more serious as time goes on. Tourism is also affected, as changes in natural environments and wildlife can make certain places less attractive. In addition to this, industries like mining also feel the impact, as environmental changes can influence operations in different ways. When all of these effects are combined, the result is a broad and ongoing economic strain. At the same time, the cane toads themselves have not stayed the same. Over the years, they have changed in ways that make them even more difficult to deal with. These changes are not just small or minor, they are clear and measurable. For example, the toxins they produce have become stronger, increasing by about 40 to 50% compared to their original state. This means they are now more effective in surviving and protecting themselves. There have also been physical changes. Their legs have become longer, which allows them to move faster and travel farther. Their bodies have adapted in ways that help them handle stress better and survive in new environments. Because of these changes, their rate of spread has increased. In some cases, they have been observed moving as far as 76 kilometers in a single year. This is a significant increase compared to how they moved in the past. What makes this even more concerning is the speed at which these changes are happening. The rate of change has been described as being 5 to 10 times faster than what is normally expected in other species. This means that the problem is not just growing, but also evolving at a pace that is difficult to keep up with. In response to this, new methods are being explored, including more advanced approaches. One of these involves the use of genetic modification. Scientists have developed a way to change cane toads at a very early stage of their life. This process involves altering a specific part of their biology that is responsible for growth into adulthood. By doing this, the tadpoles are unable to develop into adult toads. Instead, they remain in their younger form for their entire lives. These modified tadpoles grow larger than normal and stay in the water, where they feed on cane toad eggs. Because they cannot reproduce, they do not add to the population. Eventually, they die without producing any offspring. This approach offers a very different way of thinking about control. Instead of removing toads after they have already spread, it works by interrupting their life cycle before they reach that stage. However, this method is still limited. It is currently being used only in controlled environments, such as enclosed water areas. It is not yet ready for wide use in open environments. Even with these limitations, it represents a step toward a new kind of solution. It shows that the approach to this problem is changing, moving from simple removal to more targeted and controlled methods. While there is still a long way to go, these efforts reflect a deeper understanding of the problem and a continued search for ways to manage it more effectively over time. If tadpoles are the key, how can scientists control them safely without harming other wildlife? Keep watching for more details. The Peter Pan tadpoles and their role in cane toad control. In Australia, the battle against cane toads reached a point where traditional methods were proving ineffective. The adult cane toads are extremely numerous and highly poisonous, making attempts to control them through hand collection, trapping, or night hunts largely futile. Even when millions of adults are removed each year, the overall population barely changes. Faced with this challenge, scientists realized that the solution needed to target the species at its earliest, most vulnerable stage, the tadpoles. This approach marked a significant shift in strategy, focusing not on adults, which were nearly impossible to control, but on preventing the next generation from surviving. The result of this strategy was the creation of what scientists have called Peter Pan tadpoles. These tadpoles are deliberately engineered to remain in their juvenile stage and never undergo metamorphosis. In normal development, a cane-toed tadpole will spend only about 18 to 22 days in the water before metamorphosing into a young adult, growing legs, losing its tail, and leaving the pond. Peter Pan tadpoles, however, remain in the water for 70 to 95 days. By remaining in the pond for 4 to 5 times longer than normal, they are present during multiple waves of egg-laying by adult cane toads. This extended presence allows them to consume massive quantities of eggs and dramatically reduce the number of new toads entering the environment. Peter Pan tadpoles are also physically larger and stronger than normal tadpoles. A typical tadpole weighs only 0.05 to 0.1 grams, but a Peter Pan tadpole can weigh between 0.2 and 0.3 grams. This larger size provides several advantages. It allows for faster swimming, better control over space in the pond, and more efficient access to eggs. In short, being bigger makes them far more effective hunters. In experimental conditions, a single Peter Pan tadpole consumes between 20,000 and 35,000 cane toad eggs during its life. This is enough to eliminate a complete breeding clutch. By contrast, a normal tadpole consumes only 3,000 to 5,000 eggs before metamorphosis. The difference is immense. A small pond with just 20 to 30 Peter Pan tadpoles could destroy tens of thousands of eggs in a matter of days. The design of Peter Pan tadpoles ensures that they cannot reproduce or move onto land. They remain trapped in the water, focused entirely on consuming eggs before completing their life cycle. Because they do not leave the pond or reproduce, there is no risk of creating a new invasive population. Scientists can carefully control the environment in which these tadpoles exist. They are placed only in enclosed ponds, artificial reservoirs, or water bodies where intervention is possible if unexpected problems occur. This controlled approach prevents any accidental spread into natural ecosystems, a precaution learned from previous ecological mistakes in Australia. While Peter Pan tadpoles are highly effective at consuming cane toad eggs, there are still some risks. In controlled experiments, they were observed to consume a small number of native frog eggs as well. Although this level of consumption is very low and not enough to threaten native populations, it cannot be completely ignored. This is why all trials remain in closed and monitored systems. Scientists move cautiously to ensure that the benefits of egg consumption far outweigh any unintended ecological effects. The creation of Peter Pan tadpoles represents a major innovation in biological control. By targeting the earliest and most concentrated stage of cane toads, scientists can disrupt the species' reproductive cycle in a way that has not been possible with adult toad removal. These tadpoles are not a permanent solution, but serve as a highly effective tool in a multi-layered approach to controlling one of Australia's most destructive invasive species. The project highlights the importance of precision, planning, and patience in ecological management. Every aspect of the Peter Pan tadpoles is carefully designed to maximize egg consumption while minimizing risks to the broader ecosystem, showing that sometimes the most effective intervention is not the most obvious one, but the one that works quietly, methodically, and in the right place at the right time. If tiny ants could trigger chaos and tackle the poisonous cane toads, then what might happen when a new invader arrives? Let's learn more. Australia's toxic threat, when nature fights back. Australia released about 3 million red imported fire ants into certain areas to control inland taipans, which are the most venomous snakes in the world. A single bite from an inland taipan can attack up to 100 adult humans. Even though these snakes are extremely dangerous, they rarely harm people because they live in far-off places in Queensland and South Australia, far from towns and farms. Their main food is the long-haired rat, which they hunt in cracks of the dry clay soil in their homes. Fire ants are small but very aggressive insects from South America. They arrived in Australia around 2001 and spread very quickly. These ants live in colonies that can have up to 200,000 ants and build huge underground nests that cover large areas. They quickly attack anything that disturbs them. Fire ants eat seeds, small reptiles, amphibians, and bird eggs, which makes them very harmful to the local environment. Their ability to survive in different conditions has made them one of the most destructive invasive species in the world. Scientists noticed that inland taipan numbers were falling in areas where fire ants had appeared. Young snakes, especially those that just hatched, were very easy targets. Fire ants would swarm them, sting their eyes, mouths, and noses, and often attack them before they could escape. Studies suggested that up to 70% of baby taipans were being attacked by the ants in these areas. Seeing this, Australian authorities decided to use fire ants as a way to control taipan populations. Over 3 years, they slowly released the ants in areas where taipans were common, especially near human settlements. The goal was to lower the chances of people encountering snakes without using chemicals or attacking the snakes directly. At first, the plan worked. Taipan sightings in the targeted areas dropped by about 60%. Snake nests went quiet, and farmers reported fewer attacks on livestock. But soon, unexpected problems appeared. After the taipans moved out, fire ants filled the empty spaces in the ecosystem. They started attacking long-haired rats, cutting their numbers by as much as 80% in some regions. Rats are food for eagles, dingoes, and monitor lizards. With fewer rats, these predators had trouble finding food. Some moved to new places, and some turned to livestock, which created new conflicts with humans. Fire ants themselves began to change. Colonies became more aggressive and better at working together. Some ants grew bigger jaws, harder shells, and stronger stings, which helped them take over more land and compete with native ants. At the same time, surviving inland taipans changed their behavior. They hunted at night more often, climbed to avoid the ants, and ate different food to survive. Some snakes moved long distances to find safer homes, often ending up closer to humans. In these new areas, snake encounters rose by about 40%, which was the opposite of what authorities wanted. The changes also affected plants. With fewer rats eating seeds and fewer snakes keeping rat numbers in check, fire ants farmed aphids that damage plants. This caused around a 30% drop in native grass. Less grass meant the soil eroded faster, held less water, and became a worse home for animals like kangaroos, wallabies, and emus. Some herbivores decreased in numbers, while others grew where food was still available, which disturbed the ecosystem even more. Today, fire ants are far more than the original 3 million. They have spread into new areas, while inland taipans are still present, creating ongoing risks near towns and farms. Long-haired rat populations are slowly recovering, but predators that rely on them are still affected. Experts say this shows how ecosystems are complex and delicate. Even carefully planned actions can lead to results that no one expected. Managing fire ants and displaced snakes now takes constant attention and effort. Australia's use of fire ants to control taipans shows that trying to control nature can create new problems. It also shows how species are connected in complicated ways. The inland taipan remains in its habitat. The fire ants have multiplied and spread, and humans are facing the side effects of this decision. This situation is a clear reminder that actions in nature often bring consequences bigger and more unpredictable than anyone expects. What do you think about the unexpected hunter of the poisonous cane toads? Share your thoughts in the comments section below. Thank you for watching as we uncovered the explosive story of Australia's venomous wildlife and the fire ant experiment. If these insights into snakes, invasive species, and nature's unexpected twists kept you intrigued, don't forget to like and subscribe. Click the next video on your screen to dive into more stories. See you there.